Hello, I'm Earl Haas from SolidWorks.
And I'm Susie Stitzel from Esko Artwork, and we're here to talk to you today about improving your 3D packaging design process. At this point, I'm going to hand this over to Earl, and he's going to tell you a little bit about SolidWorks.
Thank you, Susie. SolidWorks has a strong heritage in the engineering and design community, and since its founding has continually focused on innovation and helping customers design better products through the use of 3D CAD. SolidWorks is focused on the success of its customers. In fact, more than 90% of the functions and features within SolidWorks software are a result of customer feedback. SolidWorks also has a strong history of innovation and invests in its technology to help customers be more successful. The company owns several patents on technology that are now standard features found in all 3D CAD packages available today on the market. Many companies today face significant competitive pressure from globalization and low-cost competition. To succeed in this market, companies need to respond to several significant business challenges. Innovative products can create new markets, allow for success in commodity markets, or allow for premium pricing. Faster time to market allows companies to reach the market ahead of the competition, introduce new innovative products more frequently, and reduce costs for new product innovations. Reduced product development costs can also be achieved from areas such as less development time, fewer development resources, fewer ECOs, or fewer prototypes. Product costs can be reduced by such things as weight reduction, use of fewer raw materials, modular design, and the reuse of parts. SolidWorks is dedicated to helping its customers design better products. We help achieve this goal through several unique capabilities. The tool should not get in the way of the design. By making the tool easy to use, the designer can focus on the product design rather than the use of the tool. Focus on design, not CAD. The most important measure of SolidWorks' success is the success of its customers. SolidWorks has an arsenal of successful customer implementations around the globe in every industry. Thousands of our customers have published success stories and serve as references for SolidWorks. Our customers are the best and most vocal advocates for SolidWorks. Here's a small sampling of the types of successes that our customers have achieved with our tools. Now let me turn it over to Susie to talk about Esko Artwork and SolidWorks.
Thanks, Earl. Why Esko Artwork? Esko Artwork is the global leader in packaging and prepress and printing solutions for the packaging market. We have strong product, technology, and patent portfolios that cover the entire packaging design lifecycle strategy. 9 of the 10 major brands of packaging were produced in some way or another with Esko tools. And there are over 10,000 seats of ArtiosCAD in use worldwide at multiple sites. We also have a very strong market strategy and strong partners. We believe that this gives us a value-added solutions of hardware, software, and services put together to create new business development initiatives and to expand service offerings for our customers. We also have very strong partner relationships. One of them is Adobe, a leading provider of graphic design applications used in packaging. Today we're going to talk about our relationship and our partnership with SolidWorks, the market leader in 3D modeling and product design. If we take a look at the packaging supply chain, you can see that there is a product design phase very upfront at the beginning of this, and once the product is completed, then we need packaging for that product. And there are really 2 parallel workflows that run along here. Across the top, you can see that there is a graphic-oriented workflow where we do graphic design, pre-press, proofing, and making plates for the printing press. And along the bottom, you see another workflow going at the same time with structural design, CAD/CAM, sample making, layout, die, tool making to finish the product. And these parallel workflows don't necessarily interact, and our goal is to try and integrate this workflow so that we get a better result and faster time to market. Esko Artwork is active in the areas that you see here, so a lot of graphic design and prepress tools, but also a lot of structural design, die making, and tooling. And SolidWorks is actually very active in a similar area, certainly up in the product design area. Industrial design of products is a strong point of SolidWorks, but also SolidWorks is used in some other areas of CAD/CAM, tooling, things like that. So we have a strong synergy and a large overlap here, and partnering together gives us a stronger attack on this packaging supply chain. When we talk about the SolidWorks Esko artwork synergy, we see that the products actually have some nice overlaps. SolidWorks is the market leader in 3D product design. Esko's ArtiosCAD is the market leader in structural design for packaging. And Esko's DeskPack is an integrated structural and graphic design toolkit using plugins in Adobe Illustrator and Photoshop for graphic design. We'll be talking today about the SolidWorks filter for ArtiosCAD. This allows the CAD application to natively import SolidWorks parts and assemblies, and to design packaging directly to the imported 3D model. This enables us to virtually do packaging design without the need for the actual product, based simply on the 3D model. The value proposition here is that product marriage between the two products shows us a strong synergy, but also we find that we have many common customers, and many of them requested this type of integration, which makes this a natural for us to do. And what we've also found is that this dramatically simplifies package design by giving us increased speed to market, reduced errors, and enhanced efficiency, and designing really truly packaging that fits the first time, every time.
We are going to have two demos that show the power of SolidWorks and ArtiosCAD working together. In the first demo, we are going to take a look at how SolidWorks can be used to create the plastic clamshell packaging for consumer goods such as this electric carving knife. I've started the demo here by creating the initial packaging, and so let's show that where I'm at this point. We see the front side of the clamshell, and naturally we're going to need a back side of the clamshell. The portion of the clamshell that we're going to work on, we're actually going to finish up the backing by creating a pocket for the portion of the carving knife handle that's protruding into the backing, as well as to create a pocket for the cabling and instructions and so on. So to get started with that, we're going to get rid of the carving knife handle and put this guy into edit mode. In order to bring that surface into our clamshell, we actually need to take a copy of it from the front portion of the clamshell. We'll do that via an offset of that body. That just simply brings a reference into the backing. I no longer need the front, so let's get rid of that. Now, we only need the portion of the handle that's actually protruding. So let's trim that surface body up into the portion that we need. And we'll do that using the trim surface and trim it to the backing itself. Having done that, we can hide this body so that we can see just the surface portion of the handle that represents the pocket that we're looking at creating here. I need to add that to the backing, so let's make that into a surface, into a solid body, by adding a capping face to that and sewing the two surfaces together with the knit surface feature. That gives me a solid body here. Together with the backing, we can combine those into a single solid body. Right, so we now have the surface attached to the backing, and it's a single solid model. Let's finish that up by adding a fillet around the model just to clean up the edges. Okay, so the next step is to create the pocket for the cabling. And I'm just going to do a simple extrusion and create a simple rectangle right there in the back of the model. And we're going to dimension this rectangle 1 inch from each side of the backing so that we can reference this. One more, and we'll give it a specific height of, say, 2 inches. So we're finished with that. Because I selected the extrude feature, of course, it goes straight into that operation. So we can extrude that profile. Let's make it 2 inches as well. And because it is a molded part, let's add some draft to that. I think 4 degrees would be appropriate. So that gives us our pocket, at least the starting point for this pocket. Let's clean up its edges by adding a fillet to all of the edges. We'll just use the same fillet that we've been using all along. And that gives us the protrusions on the back. To finish up the pockets, we're actually going to use the shelf feature to shell the backing and grab some of the faces that we're not going to take part of the shelling. And finish the feature up. So we're at this point, we now have the model that we're looking for. We'll go back in and bring in the rest of the assembly, show those back, and we see we have our model, our assembly completed and ready to go. We can now take this assembly and pass it over to ArtiosCAD to generate the cardstock that will go in to the clamshell for packaging.
Here we are in ArtiosCAD, and we're going to bring in that clamshell that Earl was just working on. And when we open the file, we can open SolidWorks parts or assemblies using the SolidWorks filter for ArtiosCAD. I'm going to pick the assembly, and you'll notice that if there are different configurations, that I can select a configuration that I want. I'm going to take the backside, and the backside comes into ArtiosCAD, and from here we can actually make the card backer. So we have the backside, which is just the back clamshell and the handle itself. We want to make a backer card that fits in this area and actually goes around the handle of the knife with a cutout for that area. To do this, we're actually going to turn it sideways and we're going to cut a cross section. And when we cut a cross section, we use the cross section tool. And the thing that we can do is we can actually choose a material from a large list and library of materials that you can see here. And by picking this material, we know the thickness, the caliper, and how to actually design this cross section. I'm going to start to draw the cross section now, right through this area, and I'm trying to hit the middle of the flange because I actually want it to go inside the flange. So drawing a cross section with that chosen material, and when I say OK, ArtiosCAD is actually going to create that cross section, complete with the going around the outside of the flange, and we can see it here. And I'm going to edit this because what I got was the outside, and what I really want is the inside. So I'm going to get rid of the outside edges that I don't want, this area and also this crease over here. And now I have the inside area, but this fits the outside of the flange. So we're going to shrink this. We're going to use the tool here to actually offset the lines by, I don't know, something like 8 millimeters and to be the inside of the flange. And we're going to get rid of that outside area that we no longer need. So now this is going to fit the inside of the flange. And if I convert this into 3D, it's going to update automatically the 3D model that I already had going. Here you can see that we have the cardstock now inside the flange and also ready to go inside the clamshell, fitting perfectly. And the next thing that we're probably going to want to do is we're probably going to make a cutout around the knife handle. We're going to offset this a little bit to make it easy to assemble when we assemble all the packaging. So we're going to use an intersection tool. We'll offset this by, I don't know, 1 millimeter. And I select the object. I'm going to put some round corners on it. I select the object that I want the hole in, and it's automatically going to update that card that I created before. So here it is. We now have a cutout with a 1 millimeter offset around the knife, and if I say OK, we're actually back here in 3D, and we can see that it has automatically cut a hole in the card, made a nice offset around the handle, And this is the completed card as it would go inside this clamshell. The next thing I might want to do is I might want to give this to Earl back for SolidWorks. And so using the filter again, we'll change this around. We'll get rid of this outside area because he already has that. And I'm going to take the card itself and I'm going to export this back to SolidWorks. I'm going to write a SolidWorks file back, a SolidWorks part. We'll name it something like the, I don't know, something like the backer card or something like that. So we'll rename it. It's going to save this directly as a SolidWorks part. And then Earl will be able to use this directly back in SolidWorks, complete with the materials. So at this point, I'm going to hand this back to Earl, and he's going to show you how to complete the final assembly all the way through to the end. Take it away, Earl.
Okay, now that we have the cardstock from ArtiosCAD, let's bring that into our assembly. I will just simply do some simple mating to position. And we'll move this guy into place. That gives us our model. We see that we've managed to use the power of the SolidWorks filter in ArtiosCAD along with the power of SolidWorks to create the clamshell as well as the cardstock for our carving knife packaging.
In the second demo, we're going to take this packaging process a little bit further. We're going to package a toy fire truck, an assembly, SolidWorks assembly, this one right here, and we're going to take this further down into the process to build the packaging, but also the graphics for this particular item. So here you can see we have the fire truck. It has lights, it makes sounds, it does all kinds of things, and we're going to build packaging for it and design the graphics. I'm going to jump a little bit further ahead in the demo where I've already set up a bounding box that you can see here, including some dimensions to give me some ideas about how big this is. And this represents the cube size that's available to me in the retailer. This was given to me as the optimal cube size for the shelf space that I have. So you can see the item. It's a little bit, the box is a little bit bigger, of course, than the fire truck itself. But what we want to do now is we want to build a fitment down here around these wheels, maybe to hold it in the box, maybe to tie it off with a twist tie into the box so that we can see the product, but we can't remove it. So I'm going to pick a material to create this, something like an E-flute, and I'm going to start to draw with that material. You can see that I'm drawing with corrugated material, so we know the thickness. And we also know how the material behaves. You can see as I come around these corners, it'll start to bend around corners because that's truly what corrugated material does. If I say OK, then ArtiosCAD is automatically going to create the design for me. You can see it back here. It's also made the cutouts around the wheels with a specified offset that I gave. And if I say OK, it's going to put it back into the design, and I'm actually going to see the two pieces together now. So I have the corrugated piece and also the fire truck that we're packaging here. I can tilt this up a little bit. Let me turn it up so that you can see the bottom, and you'll see that the wheels fit nicely into those holes. And we can get ready to build the box for this. That's all ready to go, and the box will go outside this corrugated fitment. So let's move on to doing the box and see how that happens. I told you that now we're going to start building the box, and we're going to use this cube size again to help build the box. We're going to do what's called running a standard. I'm going to click on two dimensions, a length and a width, and that will give me the size, and I can choose from ArtiosCAD's standard library, large library of standard designs that are parametric and resizable to fit any size and shape. I'm going to use this toy box standard. This is the one that I use for all my toys to give them a distinctive shape. And the first thing it's going to ask me is what is the material that I'm using, and I pick the material. And once I have the material, you can see that it's automatically filled in based on that optimal cube size, the size that I need for this design. If I say OK, ArtiosCAD has already created the design, has sized it to fit. It's all back here. And if I actually say OK, it will put the design back together with the fire truck and the fitment. So now we have multiple pieces You can see that we have a header sticking out the top. We're going to cut that later. You can also see the box is around the fire truck and also around the fitment. And at this point, I have a couple of different designs going. I have a design going for the base, or the internal fitment with the wheels. That's the one we saw first. And I also have one going for the carton itself, and that's this one. I'm going to go ahead and save this because we're going to use this in graphic design in Adobe Illustrator, and you'll see me doing that. So we'll be able to save this file. Maybe we'll save it as number, I don't know, 2 or 3. We've made a couple of different versions, and we're going to save this. And now we're going to move over to Adobe Illustrator. We're going to take this file directly into Adobe Illustrator. Here we are inside of Adobe Illustrator with that very same CAD file directly imported. It has not been converted to some other file format. You can see we moved ahead in the demo where we cut this header up here already. And you can also see that the file has come in and we have all the layers, the coding layers, the dimensions, all the different layers of the CAD file that we can use to create the design. It also brings along a lot of its other intelligence, which is that I can automatically ask for a 3D window, a 3D model. So here is that 3D model, just like we saw in ArtiosCAD. Of course, we've already cut the header. And by clicking on individual panels, you can see it highlight in the two-dimensional window in Illustrator, including tabs like this one. Maybe we'll move over to the back. You should be able to see the glue flap over there to the right. I can also make it semi-transparent so I can see how the flaps on all the panels interact with each other, where all the tabs are, where all the pieces are. You should be starting to get an idea now about how this 2D and 3D linkage works. I'm able to actually design panel by panel. If I come over here and I'll turn on a couple of the panels that we've already defined, the front, the back, the sides, and you can see that I can define this panel by panel, and the 3D window will catch up to me and will actually update the graphics, and now I'll be seeing the graphics actually on the 3D window, on that 3D model. Put in the top here, turn that on, and you can see we've already popped that out the top. The next thing we're probably going to want to do is turn on some copy. We had some copy in here, and you can see that the design's actually looking pretty good. We're very happy with this. We can turn it around, look at the back side, look at the different pieces that we're gonna have here, and I'm getting a pretty good idea of the design at this point. The next thing we might want to do is actually create this window that's supposed to be in the front. If I zoom in here, you'll be able to see that we've got some areas in here for the window, and we've defined the window extent, the maximum size of the window. Turn off those dimensions, and we're going to cut this window on the fly, but based on the graphics, because we have some pop-outs that we'd like to have, what we call violations, that we'd like to have in the window. So I'm going to select a layer in the CAD file to actually pull out of the CAD file and start to use as the basis of my new window. So it's automatically done that. I now have the line that gives me the window, but I'm going to combine that with some other features like some of these pop-outs. If I combine these together and then export this, I can export this back out. I'm actually going to make a copy because I don't want to overwrite the original file, but I'm going to include all the parts and say put it back in here. And you can see now that it has automatically cut the window inside the CAD file itself, modified the CAD file on the fly to match up the window with all those violations and all of those different parts. One of the other interesting features about these tools and the integration of 3D structure and graphic design is that I have some areas where I might have crossovers. For instance, this tree with the cat should cross over and wrap around the corner in the 3D model. I can actually use a tool inside of Illustrator to select the tree or any other object, select the panel that I want it to wrap from, and it'll actually distribute this in Register to the other panel. You can see it over here on the left-hand side. It's automatically made a crossover from one side to the other. Sometimes these can be very complex. This one's not terribly difficult, but it is interesting that it automatically puts things in Register. If I move this element, you'll see that I'm able to actually use another feature that says update all the copies. So every one that has been shifted will be shifted as well in their copy. So we maintain an absolutely perfect crossover. I'm looking pretty good. I like this design pretty well at this point. And so now one of the things I might want to do is I might want to share this with someone. I'm going to make this window bigger so you can sort of see what's going on. One of the other nice tools about 3DX, which is the tool that we've been using here, is I'm going to export this. I can export it to an image, for instance, a high-resolution TIFF image that I can set to have a transparent background at any resolution that I want. But what I'm actually going to use is this PDF file with a 3D design. I'm going to actually write a PDF file that has a 3D model embedded in it. I'll save it on my desktop. And I don't know, we'll call it, I don't know, the SEL fire truck. That's our brand name. I'm going to save it to the desktop, and it's actually going to create a 3D model embedded inside of an Acrobat file. What this means is that I can share this with anybody who has the free Acrobat reader, and they'll be able to look at this. I'll switch over to my desktop at this point. Here's the file that we were talking about, and if I open this, it's going to open in Acrobat. Anyone with the free Acrobat reader can manipulate and look at this model. So you can see inside of Acrobat, I'm simply turning this around. I can use different tools, for instance, to zoom in and zoom out, look at different features of the design. Down here we have our company logos pasted next to the tree. This was that crossover that we made with the tree, and here we can see the cat on the other side of the building wrapping right around this tree. So anybody with this free Acrobat reader or Acrobat themselves can manipulate this and actually look at the design.
Today we've seen two demos highlighting the synergy between SolidWorks and ArtiosCAD. In the first demo, I used SolidWorks to create the molded clamshell for the packaging of these electric carving knife. Once I did that, I then passed the model over to Susie, who then used ArtiosCAD to create the cardstock insert for the packaging. The result was this packaging of the carving knife, including the cardstock.
In the second demo, I showed you how we took the toy fire truck that was created in SolidWorks directly into the CAD application and ran a parametric standard to create packaging that fits the model. From there, we opened that file directly into Adobe Illustrator, and using the DeskPack plugins, we were able to create the final packaging and the branding that matches the fire truck image. Our final result was a complete product plus its packaging. We've seen how we can create branded packaging elements that reflect the playfulness and the design of the fire truck. Our special thanks go to Laga, who created the graphics for this presentation. Earl and I hope that you have enjoyed our presentation today, and it should be obvious that working this way with the 3D models and the integration with 3D packaging design is a huge benefit. You can start working this way today. All the tools that we showed you are commercially available right now today. If you want more info on Esko products, ArtiosCAD, or the SolidWorks filter that we showed, please contact info.usa@esko.com. or by phone 937-454-1721. And if you'd like more information on SolidWorks products, you can contact SolidWorks at info@solidworks.com or by phone 800-693-9000. Thanks a lot for your attention, and I hope you enjoyed our presentation.